Hello everyone, my name is Renuka, Assistant Professor in Department of Electronics and Communication, Maharaja Institute of Technology, Mysore. If you remember, in the previous class we had dealt about what do you mean by real-time system, the evolution process as to how real-time started from a simple monitoring system to the present real-time system, right? And not only that, we also studied about what are the major constraints in a real-time system, right? And we also dealt about how do you get the output with the feedback loop, what is the control system. There are so many definitions that we try to define in the previous session. So now today we shall learn about what actually does a real-time system means, and what are the basic classification under the real-time system, and how is it dependent on the time constraints and its performance and other aspects. So if you just remember, in the previous class we had dealt about what is the input image, what is an output image, what are the input task, output task, and now today we are going to find out how we are going to reduce the entire block into a simple control system. So this is a simple block diagram which talks about the simplest continuous control system. So it is called as a continuous system because if you just see, there are abbreviations like RT, ET, MT and CT. So what happens is there is a feedback loop. So the small amount of output from the plant is fed back to the input, okay, and even if there is a small difference in the performance could be corrected. So that is taken as error, okay. So this is a correction factor E of t, and that will be controlled by the control system, and then you have a message and this continues. So this is a simple sequential, I can call it is a continuous control system, okay. So this control system is the major simple block diagram which is concised looking into the previous example that we've already dealt. So now the software task now can be divided into three major areas. What are those? One is called as a plant input task, plant output task and a control task. So what do you mean by plant input task, output task? For example, if I'm an operator, okay. So now the operator has a capability to give the input to the plant, okay, and also monitor the output. So whenever you have an operator involved in both input and the output task, then you have this RT and CT. But what happens in the control task? Control task is not connected directly to the input, right? So it is like this is a complete different entity and you have CT to be a different entity. So that is input, output task is monitored by the operator, but the control task is completely based on the control system of a plant, okay. So that's the reason why we have to have software task which has to be divided into what are the input task, what are the output task, and then we have to define what is a control task. Next, the simplified block diagram of sampled feedback control system. What do you mean by that? So when you go to the previous example, if you just look into this block diagram, you have RT, ET, MT and CT, correct? So here, if you have sampling, because whatever output you obtain is mainly based on what? It is a time constant, isn't it? So when you have a time constant, then you have to sample those time constants, right? So the greater the number of samples, smaller is the duration of time, isn't it? So if you just see here, n represents the number of samples, okay? So R n of t, E n of t, U n of t, and U of t and C and t, these are all what? These are nothing but the sampling instance. N is nothing but the number of samples that are required in order to get the output, input driven towards the output. And then it will be controlled by this T switch at the feedback loop, okay. This is a simple simplified block diagram of a sampled feedback. So it is discretized, okay. It is digitized. So you have a discrete level of samples that is being connected to the feedback loop system. So if you just see here, sharing of computer control within the site and between the computers. What do you mean by that? So If you consider a computer which is a single computer unit, if you consider this as a computer unit which controls one complete plant, so it can't be defined to one single site, isn't it? You have to think about inter-computer communication interchange. So there should be transferring and receiving of data not just in single site, the area which is which is boundary limited, it should be interfaced to other computers. So message should go from one computer to another. So sending, receiving of stimulus from various processors is considered. Now, so that's the reason sharing of computer control within the site and between the computers was the next priority. Okay, communication task, remote transmission, graph plotter, LAN WAN came into being because of the intercomputer interchange, the interfacing between two different computers even in the remote space. Fine. Communication can be sequential or parallel concurrent. What do you mean by that? So communication here, when I have a computer here, computer 1 and you have a computer 2, okay? So it can be sequential. What do you mean by sequential? There will be a set of instructions or a program based on which the flow will be continuous and it will not change, it will not alter. For example, if you take in programming C, so move the register to accumulator. So it does that particular operation and then you have accumulator to memory. There is a content in a memory that you have to place, right? So it has an ordered way of tasks that needs to be performed. That is called as a sequential. So what do you mean by parallel? Parallel is nothing but you have more number of operations or tasks which is being performed in the same time constraint. Okay, if you have time t as a period, within that time t you have multiple tasks that has been performed, right? So that is called as a parallel or concurrent operation. Okay, so what is pseudo concurrent leads to difficulty in synchronizing various tasks and sharing resources between the tasks. For example, if you are trying to establish a communication between one computer to another computer, okay, that is possible only if you have two computers, right? If you have single computer to control the entire control system in a plant, it is not possible, right? If you want to have parallel processing, you need to have more number of computers or processors that needs to be used, right? So sharing of resources and tasks becomes really tedious because in single computer it is not possible to have a parallel computing system. And synchronization of different tasks, using of the resources. What is the resources here? When you have input output units, right? You're using like printers, you have plotters, right? Scanners. All these are the resources that could be used while performing the task in the same time duration. So utility of these resources and sharing the time of time sharing, it becomes very tedious with single computer, right? That's the reason we call this kind of system as pseudo. It's called a pseudo concurrent controlling system, which leads to all these issues. What are the issues? Synchronization of various tasks is not possible and sharing of resources will not apt. Next. So now, knowing all this, now we have to define what is a real-time system, okay? We have a lot of other definitions given by many scientists, but we have a couple of them for you. The Oxford Dictionary of Computing, what does it say? It says any system in which the time at which the output is produced is significant. The time at which the output is produced, whatever input is there, you have the corresponding output that becomes significant for that input, okay? And this is usually because the input corresponds to some movement in the physical world and the output has to relate to that same movement. The lag from input time to the output must be sufficiently small for acceptable timeliness. What do you mean by that? Even if there is any if there is any feedback differences, then that should be reduced, okay? This is the complete definition given by Oxford Dictionary of Computing. That is how they have described. Next, we had cooling in 1991. who try to describe what do you mean by real-time operating systems. Now, real-time systems are those which must produce correct responses within a definite time. Correctness of the responses is very, very important. It talks about the significance as in Oxford, Oxford Dictionary of Computing has defined. So, there is a definite time and there should be a perfect output for the current input. Okay? Should computer responses exceed these time bound, then the performance degradation and malfunctioning results. So, you are not taking those responses which has variation in the output. So, those responses which are apt and which occurs exactly at the right amount of input, then you consider that as a real-time system. Else you can say that the system is malfunctioning. Okay, it is not correct. Next, there is another alternative definition. A real-time system reads input from plant and sends control signals to the plant at the time determined by the plant operational considering not at time limit but the capability of the computer system. So, it mainly deals with the computational capability to get those output required for the present or the desired input signals. So, it mainly focuses on how the control systems are. This is one of the alternative definition of real-time systems. But let us go to the simple definition of real-time system. Okay? A program for which the correctness of operation depends both on the logical result of the computation at the time at which the results are produced. What do you mean by that? It has a logical, it mainly depends on all the control actions which are taking inside the control system, and you have a logical result based on the computation at the time is a constraint again, at which the results are produced. So, you have a definite output for a definite input. So, computer systems that are considered for such operations are usually called as embedded computers. Now, after defining what is the real-time systems, okay, now let us try to understand the classification of real-time systems. How did we classify? Interfacing between receivers and sends variety of stimulus. What do you mean by that? So, you have a computer, you have a responder. If you just look into the block diagram here, you have number of processors, you have an input device, output devices, and then leaving this block you have what are this? These are all communication devices, right? So, these are nothing but the external processing units which are connected to the control system, and this becomes the input and the output devices. So, these are the external devices and you are trying to connect this input to the through control to the external world. Like for example, visual display units, keyboards, then you have LAN and printers. They are using what? They are using a communication interfacing, correct? So, now you have different stimulus. Stimulus is what? Giving certain degree of input for which your respective responses are required, right? So, interfacing devices receives and sends varieties of stimulus. So, for example, I have a keyboard, okay, which is an input device. Now, I try to key in some information, that becomes an input device, right? So, that will be controlled, and definitely when you key in, there should be a monitor out, right? So, what happens? That becomes your display unit, right? So, there is a variety of stimulus, fine. Physical devices are connected externally to the computer. What are the physical devices? As I have told you, it is VDU, keyboard, LAN, printers. All these are all physical devices which are usually connected externally to computer. Here computer means the computer control systems. Okay. The time scale in computer is same as external processes, real time. What is time scale? The time duration at which the process will take place, the performance of the entire task, that becomes your time scale. T is your time scale, the period. Okay. The internal action carried out as per the scheduled clock base. So, if there is an internal action which is carried out as per the schedule. So, if I am scheduling an operation say about 5 milliseconds or have a clock duration of 5 milliseconds. So, that happens internally within the controller, then you call it as clock based. So, you are providing a clock for operating at certain duration of time. Next, you have event-based. What do you mean by event-based? Event-based are nothing but closure of valve or switch. For example, you have a boiler, okay, the valve will open and close, right? That becomes an event. When will that event occurs? If it depends mainly on the entire control system. If it says that, for example, you have a motor, you have a overhead tank, correct? You switch on the motor, what happens? The water is driven and it completely fills. And after a certain duration of time, you try to switch it off. Why? Because you know that there is a limit set for a tank, right? So that limit of closing and opening is done through the control system, okay? That becomes one example of event based. This is called event based. So obviously there will be a limit, that is a minimum and the maximum, fine? Next you have interactive action in computer and the system. Then you have completion of a task in predetermined time. What do you mean by interactive? Interactive is nothing but just like you go to an ATM, okay? You have a card, you just swipe in a card and what happens? There is an interactive board where it tries to communicate to you and there is a stipulated time for each and every action, right? So what do? You try to key in your PIN number, right? Then after a few seconds, if you don't do it, within that stipulated time of 20 seconds, what will happen? It automatically goes off. You have to try it again, right? So that becomes interactive. There is a time bound, but it is not, it is mainly dependent on the control system, how the internal control system want the performance to be done, the output, right? So if you get the, few seconds, for example, even OTP, what you get for banking, online banking, what will happen? It usually says after a few seconds, 15 seconds of, about 54 seconds, you will not be able to access the code. You have to retry it, right? So what is happening there? You have a stipulated constraint of time where the operation has to be dealt. So that becomes what? It is interactive. Okay, that is a communication task. So control task also operates in real time. So what is control task? Control task is not directly connected to input or output, okay, or the output processors. It is actually through the input devices, you have the output devices being connected. So it is like control task is also operated in real time. Until unless it is operated at a real time, you will not have a, the exact or significant response for a present input. So this is a main classification, how you have to think about the real-time system, whether it is a clock based or event based or is it interactive based. Now let us get into details of what do you mean by clock based task. They are also called as cyclic or periodic, okay. Plant time constants. What is plant time constants? Time constants, as I have told you in the first block diagram, when you saw, you have a feedback loop, correct? You have a time constant which is fed towards the input, that is the sampling duration, how fast you have the sampling. So the sampling of time is mainly dependent on the time constant, and this time constant will tell you about the performance of your computer controls, right? So time constant, plant time constant is a very, very vital, important information for any to even judge about the performance of your computer, okay, or the control system or any system for that matter, right? Measured in, it can be measured either in hours or in milliseconds. What do you mean by measured in hours or milliseconds? For example, if you take a chemical processing unit. In chemical processing unit, you have certain amount of, the concentration levels to be attained. So it might take hours of, experiments. But in case of air traffic control, wherein taking off, landing, okay, it needs only few milliseconds, isn't it? So it can be measured even in hours or even in milliseconds. Next, the feedback control is dependent on time constant sampling rate. As I've told you earlier, time constant is very, very important, because if you have smaller duration of time, you have greater number of samples, right? So now what happens is the control system should be synchronized to a real time to carry out measurement, control actuation within each time interval. What do you mean by that? Whenever we are talking about synchronization, okay? So I have a motor which is running. I have to control the temperature, the valve. So what is happening? You have to synchronize. If you want apt temperature, you have to synchronize the gate valve as well as the movement of motors, right? So what happens? You need to have a simple clock pulse. Synchronization is nothing but a simple clock pulse is added on as an interrupt, okay, between any two events. Or it might be the clock pulse itself could be initiated as the result of an event, okay. So instead of just controlling, even a real-time controller or a computer system should be able to, what should we be able to? Not just the real time, it should be able to measure, control and actuate, okay, with whatever the time sampling has occurred in the system. So the number of operations are, so what happens? The number of operations and speed. If the number of operations are greater, what will happen to the performance? For example, if I have to perform say 1, 2, 3 tasks within 1 hour, okay, I have 10 tasks to perform in 1 hour, what will happen to my speed? Initially it will be high, but later on what happens? It deteriorates, right? So what happens? The number of operation, if it is increasing, what will happen to the speed? Definitely it will decrease. So lesser the number of operation, better is the speed. Next, coming to definition. So let us try to define what is synchronization. It's obtained by adding a clock to a computer system. It is also called as a real-time clock. Helps to interrupt the computer during predefined fixed time interval. As I've told you earlier, task 1, task 2, if there are 2 tasks, you have a synchronization clock pulse. That is a real clock pulse which adds up an interrupt saying that after the first task, please go for the second. Okay, that is called as synchronization. Clock interrupt is used to keep a clock and calendar both aware of time and date. So clock interrupt is what? It is just, when you sleep, you have an alarm, right? Set. Why do you want an alarm? Because you don't want to be late for any other, promises that you have made for yourself. So you keep a reminder, right? Similar way, we have a reminder for a computer. It reminds not just about the time, but also about the calendar, that is about the date. So that is called as a clock interrupt. So clock-based tasks are called as cyclic and periodic tasks. They are called as clock-based, usually are cyclic. What do you mean by cyclic? It goes on, one after the other, and it is periodic. One task, after one task, you have the next task, it goes on systematically. So it is called as periodic. Event-based task, we all know that event can happen anywhere, anyhow. It is not under the control of the external world, but it can happen within the system. For example, if it is a nuclear plant, okay, if the nuclear reactor, there are so many devastation which has happened in Hyderabad, correct? You know about it, right? So what happens? You don't know about the event. You don't know about the chemical reactions which happens, right? So what happens? The event based is always internal. Based on the internal variations in the control, there could be some, disaster. Catastrophic disasters could happen, right? So action performed based on responses of some event. It is simply the action which is being performed or based on the response of some event. Response of some event, for example, if, as I've told you earlier, this previous example, the water level has reached from the bottom to the top, and if it reaches at the valve, at the ball point, what will happen? You say that the event has completed. So what happened after that? You have to switch off the switch, right? You turn off, switch on, off, and valve on, off. These are all based on event. Extensively used in alarm. These are the alarm conditions and initiate alarm action, high pressure and temperature. Probably even you have, about the smoke detectors, correct? And fire alarm system. All these are some of the examples of event-based, okay? based on the temperature variation. Okay, if it increases, there is an alarm. There is an indicator which helps the operator to go and attend that scenario then and there. Then you have system to respond within a given maximum time to a particular event. So system to respond within a given maximum time. So maximum time is a duration for which you have to respond. Small system use polling or even the interrupts are used. Interrupts is nothing but, as I've told you earlier, it is just adding about synchronization or a real-time clock pulse. Or polling is what? Polling is nothing but based on the priorities. Okay, so the computer will keep the top priority. Okay, for example, you are typing and you have something to read simultaneously. So what will happen? Whichever gets a higher priority, that will be attended first. First will be the interrupt. Next will be the saving of the program, and next task would be considered. So that is your simple logic of polling. They have start time and finish time. That is, for example, 0.5 seconds is a start and it could end. What do you mean by that? Start and finish time for an event. If I say there is a marathon that is going to start another 5.5 seconds. So after 0.5 seconds, you have the marathon, right? There could be an event which says that the finish line will end exactly. The world record could be broken within 0.5 seconds. What do you mean by that? It is well within that bound. You have to get your world record, right? So you have, you have a maximum and the minimum, or you can say the start and the end in case of a event-based or event-based task, which is aperiodic in nature. What is the interactive system? Largest class of real-time systems are like reservation system, ATM. These are all some of the examples of real-time system. We all know that. Expressed as average response time must not exceed, which means average response time. I have already explained to you how you have to stick with the time duration, else you have to retry again. So that becomes your interactive. So you have clocked, you have event-based, and you have interactive systems. Next, coming to the important logic, which is called as the time constraints. Okay, real-time systems are basically divided into two major categories. One is called as the hardware, okay, hard real-time, another is the soft real-time. What is hard real-time? It is like hard bound. You have to follow, else there will be a problem. There is some issue in the system itself. Okay. Soft real time, as the name itself indicated, is soft real time. Even if there is small variation in the computation or writing a program, that could be always corrected. But in case of hard real time, you have to ensure the correctness of the response for a desired input system, right? So now let us try to know what do you mean by hard real time. These are the systems that must satisfy the deadlines on each and every occasion. For example, the hot air blower used to dry a component at 50 degrees Celsius, T, which is time is taken as 10 seconds. Let us take the simple example itself. If I have to dry a simple component, okay, I have an air blower. What do? If I expose this, because by now you know that what do you mean by air blower, which has a temperature controlled, correct? Temperature controlled air, which will be emitted, or you can say released, because of certain control system in a plant, right? Now you have a hot air which is being placed to dry a simple component. So if there is a constraint, there is a time constraint saying that you expose this particular component more than 10 seconds, then there might be a problem in the system. The component itself could melt, okay, and if it reaches at 50 degrees Celsius, then there might be a problem with the component, okay. The component might get it might catch fire, okay, even with the air blower. So this becomes a hard real-time system, okay. What is a soft real-time system? These are the systems which is an occasional failure to meet the deadlines, does not comprise the correctness of the system. So even if there is any error in the system, what will happen? The correctness of the system could be dealt. Okay. For example, ATM customer card. So if you just can't get the cash at once, you don't stop, right? If you really want it, what do? You again go back, try it and get quicker responses, operate, interact with the ATM. Then what do? You get a cash at the whatever cash you want, you could draw, right? So that becomes your soft real-time system. Okay. So this is the block diagram which shows that for every TS is a sampling time. So what should it do? Within this time constraint, this is a time constraint. So it is supposed to what? It should first take the analog information, whatever the key, you press the key on the board, then that will be converted into digital coding. The control calculation happens and then it should be dealt, and then it should go to the heater driver. Here we are taking an example of a hot air blower. Okay. So what happens? Temperature has to be controlled, analog to digital conversion is taking place, then you have a control calculation has to happen. After this time t seconds, then it has to go back to your heater driver. So this becomes your time constraint. If you don't do that, what will happen? There might be excess of heat through which the small component can melt or catch fire. Okay. This is one of the simplest example of what do you mean by time constraint. Next, coming to hard time constraint obviously represents much more serious or severe constraints on performance of a system than the software constraints, and such systems present a difficulty challenges both hardware and software designers, definitely, because designing of hardware which is compatible to software is very tedious. It becomes very tough for any designer to have multiple hardwares being connected, okay, because each will be interleaved with different time scheduling, different operation technique, different sequencing in them and different event. Okay. So timing plays a very vital role in operation of hard real-time systems. So these are some of the expression which shows that hard real-time system not depends on the nth factor. Nth factor is nothing but the number of occurrence of the event. But in case of software, you have a number of occurrences taken, because irrespective of number of times, you can definitely go ahead and try with software system, but not with the hardware. Now, coming to the classification of the programs. What are the classification of the program? Differentiate between, first of all, you need to know what is a real-time system and non-real-time system. You might feel that all the systems are real-time. No, they are not. So first you have to define what is real-time, what is not real-time. So non-real-time system usually are called as standard procedures or standard processes. Okay. So while in 1979 he indicated 3 different types of programming. The first programming is called as sequential, the second is called as a multitasking, the last is called as a real-time. What is sequential? We have learnt about it. Sequential is nothing but you have, for example, move register to accumulator. Content has to move. So there is a specific command and a specific operation has to be performed at that time when it is read, and it is orderly mannered. So that is called as sequential. When it comes to multitasking, what is multitasking? Concurrently operating. So here in sequential, you have time duration. After one task, then it goes for the second task, then the third task. It is sequential. Okay. But in case of multitasking, since you have many tasks to be performed in a single time constraint or single time duration, then you will not be able to find out where exactly has the event has started. Okay. You can't trace out. You can't trace out at this particular duration of time this has completed. No, it cannot happen. There will be another program that could run in the same duration of time. So in multitasking, several actions are performed parallelly and tasks are proceed to what happens, it increases definitely the speed. Then coming up to the real-time system, actions are not determined by the designer but the environment. They need not wait for synchronization. In real-time systems, for example, it will just talk about, the entire system will not have The internal control system will never have a control, because the in real-time system, it is based on the environment and how the system is going to behave for the with respect to the external environment. Okay, it is not about the internal control system. So that becomes real time. Thank you for joining.